Hi and welcome to part 2 of sketching linear graphs. Part 1 was about sketching linear graphs with the intercept method. This video will be on the second method, which is the gradient and y-intercept method. So for this method, you must have the equation or the rule that you're using in this format, y equals mx plus c. If it's not in this format, then it won't work, what I'm about to try and do. Okay, so we have to put it in this, and basically what we're asking is the y-intercept, which we've looked at before when x is 0, and we're looking at the gradient, which is m, and that's the rise and the run. Okay. So, for example, my first question I've got here is y equals negative 2x plus 8. I can see that negative 2 is my gradient and 8 is my y-intercept. I can find my y-intercept by making x equal 0, but I can always just have a look at it from my equation there. So I get the point 0, 8. And what I'm going to do is I'm going to use this point 0, 8, and I'm going to apply the gradient to this. I know that the gradient is actually negative 2. It's really, I guess, negative 2 over 1. Okay, all numbers are actually fractions. Sometimes they just have a 1 on the bottom. So this means that it goes 2 down and 1 right. So from 0, 8, I go 2 units down, which will get me to 0, 6, and then 1 unit right. So I end up at the point 1, 6, and that should be a 6. I don't know if it is, it's too small anyway. So now I've got 2 points, 0, 8 and 1, 6, and I can draw a straight line between the two, and there's my linear graph. The only thing I will mention is that, in year 10 and year 11 and 12, what I want you to do is I actually want you to label this graph, this point here. Okay, I like you to always label the intercepts. So therefore you would have to find out when y equals 0 and solve the equation there as well. But that's what the shape of the graph looks like just by using this method. Okay, let's have a look at another question. Here we go. I've got 3 plus y equals x. I have to turn that into y equals mx plus c, remember? So therefore, that turns into y equals x minus 3 on both sides. I know that my y-intercept is negative 3, and my gradient, well, there's nothing in front of the x, so that means my gradient is 1. Or 1 over 1 if you like to put it that way. So it means it goes 1 up and 1 across. So from 0, negative 3, 1 up, 1 across will get me to 1, negative 2. I've got two points now, draw the straight line in between the two, and I'm very happy. This next one is, again, I have to rearrange it because it's not in the format that I like. It's not y equals mx plus c. I have to rearrange, and so I guess I'll firstly rearrange over here. I've got 2y equals negative x minus 6. But then I've got 2y, and I don't want 2y, I want 1y. So I have to divide everything by 2, which means I get negative a half x minus 3. Now I know that my y-intercept is just negative 3, it's that number there. My gradient is the number in front of x, which is negative a half, which means 1 down and 2 right. So I find 0, negative 3, I go 1 down, 2 right, and I end up getting the point 1, negative 5. Straight line between the two, and I'm very happy. Okay, I think the last question, there might be one more after this actually. I've got this graph here, y equals 4x. Now this is where, if you were using the intercept method, you'd kind of come unstuck a little bit, because you'd say, all right, I'm going to find the y-intercept, x equals 0, that's fine, I get y equals 0. And then if I wanted to find the y-intercept, I'd also find the y-intercept of 0 as well. So I'd have 2 points on the same dot point there, and that means that I can't draw the graph because I don't have 2 points to connect. So for this kind of graph, it's actually probably a little bit better to use the gradient and y-intercept method. So first I find the y-intercept, which is secretly there. We just couldn't see it before. It's 4x plus 0. So the point goes through 0, 0, and the gradient is 4. 4 up, 1 across. So I get 0, 0, and I go up 4, across 1, and I get the point 1, 4. Okay? So for this graph, it was actually better to use the gradient and y-intercept method. Otherwise, I'd just have 2 points on the origin. I think my last 2 graphs look a little bit tricky. Well, actually, they look tricky, but they're not that bad at all. This one, y equals 5, it's really y equals 0x plus 5. The gradient is actually 0, and my y-intercept is 5. And so if it doesn't go up or down from 5, this graph is just it doesn't matter what x is, it's always 5. Okay, so if x is 5, y is 5. If x is 30, y is 5. In fact, it doesn't matter what x is, y is always 5. So it's a parallel line to the x-axis. And I guess the other one alongside that is this one here. If x equals negative 3, that means that no matter what y is, x is always negative 3. And I believe that that last one there is incorrect. So when y is 0, x is negative 3. And for this one here, when when y is negative 2, x is negative 3. It's always negative 3, so it's a straight line parallel to the y-axis in this case. Okay, so I guess that the summary for all of this is here. We've got the gradient and the y-intercept method. We need to have it in this form. Find the y-intercept and then use the gradient and go up or down and across. The intercept method, we have to find the x-intercept and the y-intercept. Sometimes it's easier if it looks like this, but it doesn't really matter. We find the y-intercept, which is x is 0, and we find the x-intercept when y equals 0, plot the points, and we have it. Now, I do say for all graphs, you need to find both the x-intercept and the y-intercept. That is always important. Okay, and if you were asked to find the gradient for any graph, I guess you could just read it off, this y equals mx plus c. If it's in this form, you either have to rearrange it or calculate the gradient based on your graph. So hopefully that has explained how to draw linear graphs. There'll be a little bit more in class that I'll teach you, but that's it for now. So thanks for watching.